Okay, here's your USubstitution day 1 homework. I'm going to do the front side of this sheet fairly quickly, but hopefully it'll be helpful for you. Okay, so when we're looking at these problems, we need to define a u and then rewrite the integral in terms of that u. So in this case, you can see that the 2x is the integral of x squared plus 6. Excuse me, the derivative of x squared plus 6. So I'm going to let my u equal x squared plus 6. And when I take the derivative of that, I'm going to have 2x dx. Notice that 2x dx is in this original integral. And now I'm going to rewrite in terms of u. The 2x dx is going to be replaced by a du. So I've now replaced the 2x dx. And the square root of x squared plus 6, when I rewrite in terms of u, is now just the square root of u. Now this is an easy integral to solve. This is an indefinite integral, so I'm going to need a plus c at the end. This is going to be u to the 1/2 over 1/2, which would just be 2, plus c. So when we rewrite that, it's 2 times the square root of u plus c. Looking at this next one, we have to figure out what is the derivative of what. So in this case, if we're looking at this, if we take the derivative of 1 plus 2e to the x, if I take the derivative of that, I'm going to get 2e to the x. And that, at least part of that, is in the numerator. So when I take the derivative, I'm going to have 2e to the x dx. Remember, I could have just written this as du dx equals 2e to the x, but I'm just bringing that dx over to the other side. That e to the x dx, I'm going to rewrite it in terms of u. So in terms of u, that e to the x dx, when I rewrite in terms of u, is going to be an e to the x dx is going to equal 1/2 of du. I'm going to take my 1/2 and my du, I'm going to put them in here. This is going to be 1 over u. So I can bring the 1/2 to the front. And the integral of 1 over u is just the ln of u. I need my plus c because it's an indefinite integral without the definite bounds. And I can rewrite finally just in terms of x. And I failed to do that on the first one, I'm sorry. I should have rewritten this in terms of x. This would have been 2 times the square root of x squared plus 6 plus c. And this next one is 1/2 ln of the absolute value of 1 plus 2e to the x plus c. I've mentioned before, but don't worry too much about the absolute value bars for now. Looking at the next one quickly, I have an x squared, I have a cosine, I have an x to the third. Is one of those pieces a derivative of another piece? Yeah, here it is. It's u is equal to x to the third. In that case, my du would be 3x squared dx. There's the x squared, there's the dx. So let's rewrite. This x squared dx, this whole thing, this x squared dx, when I rewrite in terms of u, I'm just going to write that as a 1/3 du. This is going to be the cosine of u. The integral of cosine is sine, so this is 1/3 the sine of u plus c, which is 1/3 the sine of x to the third plus c. Tan and secant squared, u is equal to tan x, the derivative of u is secant squared dx. So I can rewrite this as the integral of du over the square root of u, This is 2u to the 1/2 plus c. This is square root of tan x plus c. Remember, one of the nice things about these problems is we can always check to make sure we did things correctly. So remember, if I take the derivative, of this, I should end up back where I started. If I take the derivative of this, I should end up back where I started. If I take the derivative of this, I should end up back where I started. And I do there. Okay? So now let's look at the last four. And I'm just going to do the front side of this worksheet for you. The last four here are all definite integrals. Notice now we have those bounds of integration. I'm going to let my u equal negative x squared here. My du will equal negative 2x dx. That means that x dx piece that I'm trying to rewrite, that x dx is equal to negative 1/2 du. And when I rewrite this thing, I'm going to have the integral is going to be negative 1/2 can go to the front, the du can go here, and this is going to be 2 to the u. So this x and dx, the x and dx are getting replaced by the negative 1/2 du, and then this 2 to the negative x squared is just being replaced with the 2 to the u. I can also rewrite my bounds of integration. Remember, these bounds of integration up here are in terms of x. This is actually an x equals root 2. This is an x is equal to 1. So when I rewrite this thing, it's negative 1 to negative 2. This is negative 1/2. The integral of 2u, very cute. This is going to be 2u times the natural log of 2, over the natural log of 2, I'm sorry. And we're going to integrate that at negative 1 and at negative 2. All right, the next one, 1 over x ln x. If I let my u equal the ln of x, my du is going to equal 1 over x dx. So when I rewrite this thing, the natural log of e squared is just 2. The natural log of e is just 1. This can be rewritten as 1 over u. 1 over u. The du is going to replace the 1 over x dx. So this is going to be the natural log of u, and I'm going to be evaluating that at 1 and at 2. I'll go in and write the answers into this at the very end, to each one of them, but you guys should be able to evaluate on your own. The last two. Here I'm going to let my u equal the piece that is inside. It's going to be the 4x plus 1. Du is going to equal 4 dx. That dx, that dx. That dx is equal to 1/4 du. So when I rewrite this, remember these were in terms of x. I'm going to rewrite them in terms of u. So this is going to be 9. This is going to be 1. I'm going to write this as u to the 1/2 power. My 1/4 du is going to replace the dx. So that's going to be a 1/4. That's going to be a du. This is going to be 1/4 u to the 3/2 times 2/3. We're going to be evaluating that at 1 and at 9. And the last one, my u is going to equal 1/2 x. That's that inside piece there. In this case, my du will be 1/2 dx. So dx is equal to 2 du. So my integral is going to be the sine of u. My 2 is going to go to the front. My du is going to be there. I replace that dx with a 2 and a du. My bounds of integration, they were in terms of x. If x is equal to 0, u is equal to 0. If x is equal to pi, u is equal to pi over 2. So this is 2 times the integral of sine is negative cos, evaluated at 0 and at pi over 2. I'll go through and put in the answers, but I wanted to keep this under 10 minutes, so I'm going to pause it. I'll write in the answers, and then I'll restart it and leave this on for 10 seconds. Hope that was helpful. I hope you guys are having a wonderful break, and we'll talk to you soon. So I just filled in the answers there for you. The first one is 1/8 the natural log of 2. The second one is just the natural log of 2. Letter G is 13/3, and letter H is equal to 2. I'll go ahead and quickly do, I'll leave this up for a second, I'm sorry. You can pause it there if you need to. to look at the work. That's the trees. They are beautiful though. I do love a good tree. I'll do the back really quickly for you now. I won't do the last one. Number 2 is the fundamental theorem of calculus. This is taking the derivative of an integral. Remember when we do these problems, we just drop the variable piece in. Because this variable that we're dropping in is on the bottom, this is going to be negative secant of x. And the other one, we're going to drop in both of these two, and then we're going to multiply times the derivative of what we drop in. This is going to be e to the negative 3x squared plus 1 plus the square root of 3x. All of that will be multiplied times 3, and that's going to be minus e to the negative x squared, ooh, that's ugly, squared plus 1 plus the square root of x squared times 2x. I just paused it there for a moment just to make sure I didn't mess up, but that is correct. You can take a look at that at your leisure. But when our x is on the bottom there, we just can drop it in, but we need that negative sign out in front. Because remember, if we were taking an integral, it would be minus the antiderivative of the secant of t. We don't actually have to evaluate this because we're undoing the two things, but we do have to have that negative sign will live there. And the derivative of x is just 1, so the chain rule doesn't do anything to us there. Here we're going to drop in the 3x first. We're going to drop it in wherever the t is, and then multiply times the 3. That 3 is the derivative of the 3x. And then we're going to drop in the x squared. The x squared gets dropped in where the t is, and then we're going to multiply times the derivative of that 2x. Remember when we're looking at these, this t and this dt is always a different variable than the x and the x squared. They're representing different things. These are representing the bounds of integration. Right? This is representing a variable that will define the bounds of integration, whereas the variable t is telling us about the behavior of our function. We actually did number 3 in class, so if you want to take a look at that one, you certainly can. If you Google this one quickly, gosh, I should remember what year this is. I don't remember off the top of my head. But if you Google it quickly, this is a AP question. I'm sorry, I don't remember what year. It might be 2000. I'm going to go with 2012, but I don't really remember. And this is a fairly typical setup where you're looking at the graph of f, and then you have a function defined as the integral of that function f. So this function g of x is defined as the integral, or the area underneath the curve, from 1 to some variable x of f of t dt. Have a wonderful remainder of your break. I hope you guys are enjoying the warm weather at the beginning of the week. Take care.